Hello friends, welcome to my channel Clinical Biochemistry by Dr. P.K. Prabhakar. Today I am going to talk about another category of chromatography, that is thin layer chromatography. Earlier I have uploaded a few videos, a couple of videos that is on the basics of chromatography and the paper chromatography. So this is the third video in this series. So we will see the thin layer chromatography, their definition, types, principle and steps and other details we will see. Their applications, their merits and demerits we will see. So first let us understand what is the chromatography. The chromatography, as we have already discussed, that it is a basic biophysical techniques by which we are going to separate. We are also going to help in this technique is also going to help us in the identification, purification of the compounds from a mixture of mixtures. So these techniques are we are going to use both qualitatively and quantitative analysis. If you'll say this is the physical method for the separation of compounds to be separated by using two different phases of compounds, two different phases of systems. One we are going to call it a stationary phase that normally does not move, and second one is called as a mobile phase which normally moves, and through affinity as well as the partitions, compounds, mixture of compounds are going to be separated. Depending on the stationary phase and mobile phase, different types of chromatography we are having, and thin layer chromatography is another category of chromatography. So this is the basic picture of chromatography, where we have used a glass chamber here, and in this glass chamber, if you see, this is the system which is called as a stationary phase, and here in the bottom we are having the mobile phase, that is the solvent. As through capillary action, this solvent moves up onto this stationary phase, and along with this solvent, depending on the mobility of the different mixture of compounds are going to be separated into different, because their movements are different, so they are going to be separated. This is the common picture for a chromatography. Now if you will say what is thin layer chromatography, so as its name suggests, it is done on the a thin layer. So thin layer chromatography, or commonly we are going to call TLC. So this TLC can be defined as a method of separation or identification of a mixture of compound into the individual component by using a finely divided adsorbent solid or liquid. Most commonly we are going to use solid, spread over a plate, that is a supporting plate, and liquid as a mobile phase. So here also like other chromatography, we are having a solid phase, that is a stationary phase, and we are going to have a mobile phase. So this finely divided adsorbent solid works as a stationary phase, and the liquid solvent works as a mobile phase. So TLC, thin layer chromatography, is a techniques normally used for the isolation of the non-volatile mixtures. The equipment is conducted on a sheet of aluminium or aluminium foils or the plastic or glass, which is normally coated with the thin layer of adsorbent material. This adsorbent material works as that is like it will be silica, aluminium oxide, cellulose, or sometimes silica gel also. So they are working as a solid phase, solid support system or solid phase. So this is the picture of TLC, where this is the TLC, the round, spherical means round TLC chamber we are having. This is the TLC plate on this one. Here we are having mobile phase, where the bottom of the TLC plate has been dipped into the mobile phase, and on this line we have used a mixture, and according to the movement, according to their mobility into this mobile phase, compounds are going to be separated onto the TLC plate. Now if you see the principle of TLC means how this thin layer chromatography works. Like other chromatographic techniques, TLC, thin layer chromatography, depends on the separation of like other chromatography, TLC, thin layer chromatography also works on the separation principle. The separation rules on the relative affinity and the compound towards the both the phases, like stationary and the mobile phases. The compound in the mobile phase moves over the surface of the stationary phase, as we will see later on how because of this with the help of this mobile phase, it is moving on the stationary phase. The movement occurs in such a way that the compound which have the high affinity to the stationary phase moves slowly and who is having the less affinity with the stationary phase, they moves very little bit faster. So in this TLC, if you'll see that this is going to be performed on the sheet of glass, plastic or aluminium foil, which is coated with a thin layer of adsorbent material. This silica gel, aluminium oxide or cellulose, this is working as a stationary phase. And after this sample has been applied onto this plate, like on this stationary phase, a solvent or the solvent mixture, like which is called as mobile phase, is drawn up the plate via the capillary action. So from the bottom, the mobile phase, from the bottom of the plate, mobile phase, solvent rises up, and as because different analytes ascend in rises on the TLC plate at different rates, so separation is going to be achieved because their affinity along with the stationary phase is different. So it is thus based on the principle of adsorption chromatography and the partition chromatography, or the combination of both. And then also it also depends on the adsorbent, its treatment and the nature of solvent which we are going to use it. The components with more affinity towards the stationary phase, because it has to move on the stationary phase, so the compound which is having the higher affinity with the stationary phase, they will stuck and their movement will be slowly, and those compounds which is having the less affinity, they moves little bit faster. Once separation takes place, the individual components are visualized as a spot at the respective level of the travel on the plate. The nature or the character is identified by means of the suitable detection techniques. So here you can see we have used this is the chamber, TLC chamber. In this TLC chamber, this is the plate. On this plate we are having adsorbent material, that you can call it the stationary phase. Here we are having the solvent, that is called as the mobile phase, and here on this stationary phase we are going to spot the compound, mixture of compound which we want to separate it, and then we are going to put dipping into this mobile phase. As this solvent is rising up into this one because of the capillary actions, according to that one, depending on the affinity and the partition, the compound moves differently, and as it moves up on the different spates, they are going to be separated on this plate, and that can be visualized in the different spots and by the different techniques. Sometime in this TLC chamber we are also going to put filter paper which is dipped into the mobile phase, and this normally helps in the equivalent movement of the compound. So this is optional, it is not compulsory, but it can be done. This is one of the in the you can chamber, you can use beaker also as a chamber, and there you can see on this plate how separation has been takes place. So what are the different components we require in this TLC chromatography TLC? So we require four things. First, we require a stationary phase, that is called as TLC plate. Second, we require mobile phase, that is normally solvent, mixture of solvent. Then we require a TLC chamber, where the place where TLC will be kept in the solvent, mixture of solvent, and then optional will be the filter paper. A stationary phase, if you see, these are the stable and the chemically inert plates where a thin layer of stationary phase is applied onto the whole surface. It can be cellulose as you have seen it, it can be silica, it can be aluminium foils. So the stationary phase on the plate is of uniform thickness and is in a fine particle size. So that is the stationary phase. Already you have seen it. It can be aluminium foil, it can be silica, it can be a plastic on which silica gel will be there. So that is our stationary phase. Then we are having the mobile phase. This comprises of the solvent or the mixture of solvents. The mobile phase used should be particulate free and is of the highest purity of proper development for the TLC spots. The solvent recommended are the chemically inert with the sample, means it is not chemically going to react with should not react with your substance or any stationary phase. Then TLC chamber, this is used for the development of TLC plate. We are going to keep this TLC plates on into this TLC chamber where in the bottom we will have the solvent. So TLC chamber maintains the uniform environment inside the proper development of the spots. It also prevents the evaporation of the solvent. So normally we are going to covering the top of the TLC chamber. So it also prevents the evaporation of the solvents and keep the progress dust free process. Then lastly we are having the optional filter paper. This is normally moistened into the mobile phase or the solvent, and it will be placed inside the chamber. This helps development of uniform rise in the mobile phase over the length of the stationary phase. This is not the compulsory component, but if you are having option, you can use this one. Okay. Now how this process occurs, how we are going to start. So there are multiple steps. So first the stationary phase is applied. A stationary phase means the whatever gel you want to, whatever aluminium foil you want to use it, whatever silica gel you want to use it on the glass plate. So first you are going to use the stationary phase applied onto the plate uniformly and then allow them to dry and stabilize. Normally commercially available plates are available nowadays, so that will be better to use it for a better result. So these days ready-made plates are also available. With the pencil, a thin mark is made at the bottom of the plate to apply the sample spot. Then sample solution is applied onto the spot marked on the line in equal distance. The mobile phase is poured into the TLC chamber to a level which is slightly below the line where like this is the TLC plate where we have marked a line with the pencil. So when you are going to pour the mobile phase, so that mobile phase should be below this line. The moistened filter paper in the mobile phase is placed on the inner wall of the chamber to maintain equal humidity and also thereby avoid edge effect. Now the plate prepared with the sample spotting is placed into the TLC chamber so that the side of the plate with the sample line is facing the mobile phase. Then the chamber is closed with the lid. So this will be placed into the chamber and lid will be covered. The plate is then immersed such as the sample spot is well above the level of the mobile phase but not immersed in the solvent on the development. Sufficient time is given to the development of a spot that can be visualized by the solvent front. The plate is then removed and allowed to dry, and lastly the sample is then visualized under the suitable UV light chamber or any other method recommended for the given sample. Here we will talk about different size. This is the process. So this is the mobile phase, this is the TLC chamber, this is the TLC plate, and this line you are going to see where we have used different spots, and on this spot as we are going to dip it after sample starts moving because along with the solvent, and it will be separated onto the different spots. Then we are going to take it. So sample and solvent will move. For time example, if solvent has been moved up to here, so then we are going to calculate RF value. What is RF value? We will see later on. So the distance traveled by the component, like for this component, if I want to calculate the RF value, so if this spot has been traveled from here to here, that is the A, so it will be A divided by the distance traveled by the solvent. So solvent from that is called as B. So this is called as RF value. So some common techniques for visualization of the TLC plate. So what are the different techniques we are having? First, you can use under the UV light. Then you can also use iodine staining, which is a very useful in the detecting carbohydrates since it turns black in the contact of the iodine. Then you can use potassium permanganate KMnO4 stains, that is for organic compounds we are going to use it, and for amino acids normally or the proteins you can use ninhydrin reagent. So these are the four commonly used techniques for the visualization of the spots on the TLC plate. You can use any of them according to your compound you want to separate. Now what is the retention factor or RF value? Like some compound in a mixture travels almost as far as the solvent does, and some stay very close to the baseline at the origin. So the distance traveled relative to the solvent is a constant for a particular compound as long as you are going to keep other parameter constant. The distance traveled relative to the solvent is called as RF value. Like here you can see this is the sample spot where origin where we have uses the sample, and then compound starts moving in this direction along with the solvent. So this is the solvent front, means solvent moved up to here and compound has been moved up to here. So the distance from this origin to this compound is A, and or distance from this one to this sample is B. So RF value means retention factor is distance traveled by the particular compound divided by the distance traveled by the solvent. So here that is A by B. Now the behavior of a compound on the TLC plate is usually described in terms of its relative mobility. So for different compounds we are going to have different RF value. So RF value or retention factor is a unique value for each compound under the similar conditions. So if you are going to keep the almost all the conditions same, so its RF value will be same. So that is a characteristic feature. This RF value of a compound is a constant from one experiment to the next only if the chromatographic conditions are kept constant. What are the things you need to keep constant? That is solvent system, adsorbent, thickness of the adsorbent on the plate, on the TLC plate, how much thick adsorbent you have placed it, amount of material spotted, and the temperature of the TLC chamber. So if you will keep all these things constant, so RF value will be same in different experiment also. Since these factors are difficult to keep constant from one experiment to the other experiment, so relative RF value are generated considerable. And relative RF means that the value are reported relative to the standard. So along with every experiment we are going to run a standard, and we are going to compare along with the standard only. Then what are the different applications of TLC? If you will see, application of the TLC is, so it is used in the monitoring the progress of the reactions. It can be used for the identify compounds present in a given mixture. It can be used for the determination of purity of a substance. It is also going to be used to analyze the ceramides and the fatty acids, detection of the pesticides and insecticides in the food and water, analyzing the dye compound of fibers in forensics, analyzing the radiochemicals purity and the radiopharmaceuticals, and identification of the medicinal plants and their constituents for their separations. The qualitative testing of various medicines such as sedatives, local anesthetics, anticonvulsant, that is also done by TLC. TLC is extremely useful in biochemical analysis such as separation of the isolation of biochemical metabolites from its blood plasma, urine, body fluids, serum. There also we are going to use TLC. Other than that one, TLC can be used to identify natural products like essential oils, volatile oils, fixed oils, glycosides, wax, alkaloids and other compounds. It is widely used in the separating multi-component pharmaceutical formulations. TLC also used for the purification of samples and direct comparison of done between the sample and the authenticate sample, means with the standard. It is also used for the food industry to separate and identify colors, sweetening agents and preservatives. Cosmetic industry also I have told you, it is also going to be used in the cosmetic industry, and many reactions or the progress of reaction or the completion of the reactions can also be tested by this TLC. So these are the different application of TLC. So we are having very much usage of TLC. Now if you will see the advantages and disadvantages of TLC. So first advantage, it is a simple process with a short development time. It helps with the visualization of a separated compound spots very easily. It helps in the isolating the most of the compounds, and the separation process is very fast and the selectivity of the compound is very high. Even a small differences in the chemistry is enough for the clear separations. The purity standard of the given sample can be assessed very easily, and it is cheaper chromatography techniques. You don't require too much of instrumentation, you don't require too much of components. You require only three things essentially. One is TLC plate, second one is solvent mixture, and third one is TLC chamber. So that it is very cheaper and easy to perform it. There are certain limitations, certain drawbacks are also associated with this TLC. First, it cannot be going to differentiate between the different enantiomer or different some isomers. In order to identify a specific compounds, the RF value of a compound of interest must be known beforehand, so that you can identify the specific compounds. So identification can be done only if you know their RF value. And TLC plate do not have long stationary phases. Therefore, the length of the separation is limited compared to the other chromatographic techniques. TLC plate, when compared to the other chromatographic techniques, the length of separation is very restricted, very limited. The result generated from the TLC is difficult to reproduce. As I have told you, number of conditions are there, number of factors are there, which means it is impossible to keep all those variables constant. Since TLC operates in an open system, some of the factors such as humidity and temperature cannot be affected the final outcome of the chromatograms. The detection limits is very high, and therefore if you want to lower detection limit, you cannot use TLC. It is only a qualitative analytical techniques and not quantitative, because quantitative is difficult to use this one. So this is all about for thin layer chromatography. Hope you have understand it. If you have any query, any comments, you can write in the comment box. If you are not subscribed to the channel, you can subscribe it. You can follow me on different social networking sites. If you have any query, any kind of comments, any suggestions, you can write in the comment box of this video. Thank you very much. Have a nice day.